And we're back with part 2. So if you haven't watched the amazing, really award-winning performance, Do You Want to Build a Triangle? You might want to go watch it. You don't have to watch the whole thing, but you definitely might want to skip until the very end when I come up with the equation that we're going to wind up using here. It's nice to have a little bit of an understanding of why it works, and well, if you didn't get the song in the beginning too, that's quite amazing. So what we're going to look at here is the ambiguous case. So we've looked at the sign law. We worked out some examples. In this last one here, oh, there we go. In this last example here, we worked out what angle H was, and I had last mentioned that if we didn't have the diagram of the triangle, could we have possibly known what this triangle might have looked like? So we wound up solving for sine, and we got 69.7, and then we said, well, no, that's not a acute angle. It has to be 110.3. So what we're going to do is we're going to look at the case where we might not actually know what it is, whether it's the reference angle or 180 minus the reference angle. We might have an unknown or ambiguous case. So a triangle described by only one angle and one adjacent side. So that's key here. One angle and one adjacent side here may be ambiguous. So it can be drawn in two different ways. So what we have is a situation like this. If we have a triangle down here that looks like this, so this is the notation I'm using. Again, they could be any letters you want, but if sine of A is less than A over C is less than 1, then two triangles are possible and it's ambiguous. So this is a nice little formula we can use to check if our triangle is unique or not. There's a lot of modifications here. There's things like if A over C is not less than 1, then you can, I think you can only draw one triangle. If A over C is not more than sine A, you can't draw any triangles. And we sort of discussed that in that video, the absolutely amazing one with Olaf. And if A over C satisfies both of these conditions, that's the key thing, both of them, then two triangles are possible. So anyway, this was the gist of the Math Lab section 5.4. And hey, if you want to do something, you could always go back in your textbook and do it. It's very, very kind of like a cookbook sort of thing. You go through and you do the steps. So it's not a terrible thing to do, but it's not my favorite. So we'll use this here and we'll get a sense of how this works. So example, triangle ABC is described by A equals 10, C equals 16, and then A equals 30. So what we have here is, I know up here, let's see, a triangle described by one angle and one adjacent side. We also need another side. So this is actually the opposite side. I think maybe that's sort of almost like missing there, right? So it's one adjacent and one opposite side. So what we have here is we have triangle ABC is described by blah, blah, blah. How many triangles can be drawn? So in this case here, we're given A, we're given C, and we're given side A over here. So we've got an angle, we've got an adjacent side because it's touching it, and then we've got an opposite side that's all the way across. I'll tell you, it does not matter if you have A, and B, or A, and C. That's basically completely irrelevant. You could even extend this further to have like B, and A, or B, and C. What's very important in this formula is simply that one of the sides that's known is opposite to the angle that's known. Okay, so that is super important. I've probably said that a few times already, but it's worth repeating so much. Okay, so what we can do is we can use this formula. So we're going to go sine of A is less than A over C is less than 1. So we're checking this. So is it true that sine of 30 degrees is less than 10 over 16? And is that less than 1? So it has to be, all this has to be true. So sine of 30 degrees, if you use your calculator, or if you know special triangles, it's actually 0.5. 10 over 16, I don't exactly know what that is off the top of my head, but I do know that that is greater than 0.5. Well, I guess I could actually go work that out if I really wanted to. We can go to desktop, and then we can find that calculator here. Virtual TI 83, and then we'll have that right there. Okay, so we'll get rid of that. Okay, so we'll go 10 divided by 16. I know that's bigger than 0.5, but let's just get an actual number. Oops. 10 divided by, let's actually hit the right keys. There we go. Okay, so it's 0.625. And of course, that is less than 1. So it satisfies both these conditions. It's bigger than 0.5, it's less than 1, and that means we can therefore say two triangles can be drawn. Nifty. All right, so that's how we can use it. So now this part here says solve the triangle. So I'm going to move that out of the way for now. My beautiful face up there. There we go. So what it means by solve the triangles here, this is all sides and all angles. Okay, this is just a simple way of saying all sides and all angles. So what we would actually want to do here is we'd want to draw both of the possible triangles. So we have a situation where we've got angle A is 30, side A is 10, and side 16, side C is 16. So one of the possibilities, so we're going to write case number 1. So we've got a 30-degree angle here, so that's A, which is 30 degrees. C was 16, so it's all the way up here. And then side A is 10. So this could go in a couple different ways. So remember, this is a situation like where we can even go . Okay, remember the shortest distance is this here. This is like sine A. So what we have is we have one possibility where we've got the triangle that has a side length of 10, and maybe it's going to go out something like this. Okay, so that's side A. So that's A, and then the other one is C. So this is C here. Okay, angle B is up here. We were never given any information about that. Side B is down here. We were never given any information about that. And this will be our triangle. This is one possibility. Case 2 is the same setup where we've got A, which appears 30. And we've got C, which is 16. So again, that's a fixed length. That's going to go out like that. And we've got this bottom side going on theoretically forever. We've got the shortest possible travel distance, which is going like that. And then the connecting side, which is the opposite, side A, is going to start here, and it's going to go down maybe like that. Okay, so that would also be 10 equals A. And then what I would do is I would connect up my triangle. Okay, so I've got two different situations here. This would just be a little side B in this case, and this one would be a much bigger side B in this case. And then we'll call this capital B. Okay, so those are my two triangles that I could draw. What I can do now is I just have to solve them. So the way I'm going to go about this is I'm going to start by looking for something that is easy to get. I guess that's vertex C over there. So I can write sine of A over A equals sine of C over C, because A and little a is a known side angle pair, and C and angle C are my other sort of unknown side angle pair. So what we do is we go sine A equals 30 over A, which is 10. I don't know angle C, so I'm going to get that. This is 16 here. Okay, so rearranging, I'll multiply both sides by 16, and then I'll inverse sine, so I'm just going to do it all in one go. So this would be the inverse sine of 16 sine 30 over 10. So jumping over to my calculator, making sure it is in the correct mode, degree mode. Just clear that. So I go inverse sine of 16 sine 30, although to be fair, I know sine 30 is a half, but let's type it in anyway. Equals 10, not equals 10 divided by 10. Okay, so I wind up getting an angle of 53.13 degrees. Okay, so looking at my triangle, does that look right? Does this angle in here look like a 53-degree angle? Is that even reasonable? So that side C is 53.13, and the answer to that is, yeah, I think that is reasonable. Okay, so we can say that is definitely what angle C is, and as you're going through, it's maybe not a bad idea to box the things that you wind up finding. Okay, so if you know C is equal to that, then what you can say is B, angle B is 180 minus, and then we know angle A is 30, and we know angle C is 53.13. And that should be equal to 96.87, I think. And then, of course, that would be my angle B. So once I have that, once I've got that, then I'm almost done. I just need to figure out side B. So what I can do now is, there's a few ways you could do this. The easiest way is probably just go sine A over A equals sine of B over B. And then I figure out B. So the sort of shortcutty way to do this is B goes up here, A goes over here, sine A goes down there. It's kind of like a cross multiplying sort of thing here. So I'm just going to rearrange this and maybe not show every tiny little bit of the work here. This will be A sine B divided by sine A. So this will be 10 times sine of 96.87 divided by sine of 30. So we go to the calculator and we'll just type that in. 10 sine 96.87, and we'll divide it by sine of 30. Okay, and we'll get 19.85, which I'm just going to round to 19.9. And it was probably centimeters, so I'll just stick that there. Okay, so now I have angle C, angle B, and side length A. So if I wanted, I could even put this all together. I'm sort of running a little low on room, but I could say A equals 30, B equals, we'll just round it to 96.9, I guess, and then we'll say C is 53.1 degrees. And then, of course, side A, we already knew is 10. Side B, we know is 19.9 centimeters, and then side C would be 16 centimeters. And then we just do a little bit of a common sense check. Does that all sound about correct? So side B is the longest at 19.9, and it definitely looks like it's the longest in my diagram, and it's across from the largest angle, which is 96.87. Cool beans. Okay. So case 2 is doing something very similar. The only major departure is in my diagram here. When I solved for angle C, we can clearly see it's obtuse. So it's 180 minus 53.13. So that is 126.87, I believe. Hopefully I'm doing my math correctly in my head. The rest of the question is going to be done exactly the same. So it's going to be B. B is equal to, and then it's going to be 180 minus 126.87 minus 30 degrees. And that is, well, I've been doing so much stuff here in my head, I'm a little scared to do too much. So I'm just going to go 180 minus 126.87. It would be a miracle if I haven't made a silly mistake in my head. Anyway, of course, if you're watching this and you see I do make a silly mistake, well, it's a good test to see if you're paying attention, right? Okay, so there's angle B. Maybe as I'm getting these things, I'll just highlight them. And then we're going to get side B, and this is the exact same calculation, so I'm not even going to bother repeating all the explanation. I'm just going to write this out. So this would be 10 sine of 23.13, and then it would be divided by sine of 30 degrees. So we'll go 10 sine, I'll just use the answer, because that's 23.13, and then we'll divide by sine 30, and of course I could just divide by 0.5 because that's what sine 30 is, but anyway, we'll get this, and we'll get a 7.86 kind of deal. Okay, so that means we just basically repeat all the calculations, and we're going to then end up saying that the solution to the triangle ABC, A is 30, B is 23.13, C is equal to 126.87, little a is 10, little b is 7.86, or maybe I'll just say 7.9. I guess I've kind of been rounding things to one decimal place, so maybe I'll just be consistent with that. 7.9 centimeters. C equals 16 centimeters. Okay, so solved two different ways, and which one is the correct way? They're both equally correct given the amount of information that we had. Okay, and then we enter the world of word problems here. So here's a situation where two tow trucks on a straight road they're both trying to pull a vehicle from a field. Now, sometimes people have a hard time appreciating this. So what we have is we've got a situation where if I'm looking sort of top down here, like here's a road, and then maybe here's truck A, and here's truck B, and they're both trying to pull some like vehicle out from the field. Okay, so some broken down vehicles out here. There's a few ways you could interpret this. So we're told that one of the truck's cables is 47 meters and it makes a 60-degree angle with the road. So I'm going to call it this one here. This is 60 degrees right there, and this is a 47-meter long cable. Now, the one thing we're also told is that B has a cable coming out, and maybe I'll just make this look really triangular. B has a cable coming out, and it's going like that, and that's 50 meters. The one thing we don't know for sure is where is B, because we don't know the angle it makes with the road. So what we have is we have a situation where maybe B is over here, but maybe truck B is on the same side, and because it's got a slightly longer cable, maybe it's going like this. Maybe that's 50 there. We actually don't know, so this is why we've got ourselves an ambiguous case. So what we can do here, just redraw that, what we can do is we can interpret this diagram in two different ways. So we have two different solutions, and that's the big key thing. Basically, all of these questions here, you'll notice in this question, I'm not using sine A less than A over C is less than 1. It's not really necessary. It's sometimes easier to just draw the picture out and figure out what we have and what we don't have. Okay, so anyway, let's work this out. Let's say A and B are on opposite sides. So we'll do kind of the red diagram first. And you might actually consider doing this yourself if you've been sitting there doing nothing. So if you want, pause the video, give it a shot, and then we'll pause it and go over the answers. Okay, so what we should have here is what can we write? So we've got this triangle here. We've got A, B. I guess we'll call the car C. That seems to make sense. That means this side over here is side A. This side here is side B. And what we're looking for is how far apart are these bad boys, so that's side C. So we'd really like to know that. Now, what do we actually know? We've got angle A and side A, so we're definitely going to use that. And we're going to set it equal to we don't know side C or angle C, so we're not going to use that, but we're going to go sine of B over little b. So we go sine of A, which is 60 degrees, and then side A is 50. This is sine of B, which we don't know, and then this is 47. Solving for B. So we'll inverse sine. We'll take the 47 up to the other side. Don't you dare go to sigma and B calculator. There we go. Okay, so we're going inverse sine of 47 sine 60, close that up, divide by 50, and close the whole thing to make sure we're inverse signing everything, and we get 54.5 degrees. Good enough for me. 54.5 degrees. Okay, and then what this means is angle C is 180 minus, I guess we've got 60 minus 54.5 degrees. So that is going to be, let's see, that's about 65.5 degrees, I believe. And then what we can do is we can solve for side C. So it is a bit of a pain in the butt process, how we have to do this again, but this is just probably the easiest way. We will find cosine law can sometimes help out with some of these as well, and that's one of the next things we're going to learn. So what we have is, I guess, side C. If I'm rearranging for side C, now I'll give you a little tip here. If you want side C and you have all this info, I actually really like to just flip everything. I like to use the reciprocal version because it's just so much easier to isolate. We can see that when we flip everything, we just have to multiply sine C to the other side. So what we get is we get that C equals A. So let's see, A is 50. This is multiplied by sine of C, which we know is 65.5 degrees, and then we divide the whole thing by sine of 60. We type all that in. 50. Yeah, let's try the left click. 50 sine 65.5, and then we'll divide it by sine of 60. Okay, so we get 52.5, we'll just say 53 meters. Okay, the reason I'm saying that is in the question, to the nearest meter. Okay, so they're 53 meters apart, and that should seem somewhat reasonable, given that this angle up here is a 60, the other angle, I mean, the two sides were almost the same. Like, this is pretty close to an equilateral triangle. I'd expect all three sides to be roughly the same. So 47, 50, and 53 seems to make some sense. Now, that's only one of the answers. The other answer, which I'll go to the next slide for, the other one here is when we've got, and I'm just going to sketch the triangle rather than every detail here. Here's B, here's A, and here's C. So in this case, we're looking for side C here, which is this. We don't need to repeat every single calculation. What we can do is we can say, we'll just go back and we'll repeat, or we'll reuse some of the stuff. So we're going to use side B as 54.5. Yeah, no, that's okay. So if we notice here, B, if we do the same calculation, what we should wind up getting here, let's just take a little second, make sure that everything's all good. So what we have, actually, you know what? I'm not going to skip this because I think I need to show this in detail. Okay, so let's actually just break this down for a sec. I was about to say, oh, it's just the same thing, not really explain why, but I want to explain why. Okay, so this is 60 degrees in here. That makes angle A on the inside, that's actually 120. And the reason why that's 120 is because two angles on a line like this, they'll add up to 180. So angle A is actually 120. Now, the calculation to get angle B is going to look the same, but in this case, we're going to do sine of 120. And then side A here is 50, and then this will be sine B over 47. Okay, so this is actually the same calculation I had, except it was sine 60, and now it's sine 120. I will tell you one thing, though. If you actually do the calculation, so you inverse sine, you move 47 over, and you get sine of 120, and you go over 50, and you push all that in on a calculator, I can guarantee you you're actually going to get the same value as we had last time. We got 54.5, and this time we'll get 54.5. If you don't believe me, we can actually try it, and maybe it's worth just showing. So inverse sine of 47 times sine of 120, and then we'll divide that by 50. And when we do this, we get 54.49. So there's 55. So I was just, well, for 54.5, I was just about to say, well, we get the same angle just because. Now it's actually worth thinking about that a little bit. Why is it that we get the exact same angle? It's because in the first example, we did sine of 60 degrees, and now we're doing sine of 120. But here's a 60-degree angle. Here's a 120-degree angle. If you take sine of 60 or sine of 120, because they share the same reference angle, you're going to get the same value. So sine of 60 equals sine of 120. So there's the connection with our quadrant idea. Anyway, we wound up getting that. Now the big difference here with this question, and this is similar to all the ambiguous questions, is at some point we're going to wind up having a little bit of a departure in how our angles work. And it's when we calculate side C. In the last example, we did 180 minus 60 minus 54.5. But in this case, we're going to have to go 180 minus 120 minus 54.5 because angle A actually changed. So in this, we've got 60 minus that. So this is 5.5. It's a very tiny little angle. That's a 5.5 degree angle. Okay, so now we just calculate side C here, and we're going to repeat calculations from the last one. So I can even just kind of copy my calculation here. C equals A sine C over sine of A. Again, the structure, the algebra, how you do this doesn't really change. The only thing that changes are the actual values. So sine of C is 5.5 degrees, and then sine of A, of course, is sine of 120, or we could have even said sine of 60. All right, so we'll go 50 sine of 5.5. We'll go back. 5, and then we'll divide that by sine of 120. And we get 5.53, 5.5, round to the nearest meter, so that is actually 6 meters apart. Okay, so there you go. That's one example. The moral of this story here is, without drawing a triangle, it's quite challenging. I know we can use the formula, the sine A is less than A over C is less than 1, and that's certainly one approach, but when you have a word problem especially, I've always been a big fan of just drawing out the different triangles to see how it could work, and just keep your mind open. One thing I've noticed over the years is students definitely have a tendency to visualize a situation without thinking about the other possibilities. Like most people would probably visualize the situation in red because we're kind of used to nice big wide equilateral type triangles. The situation where I've got tow truck B over on the other side seems to be a little less obvious for people. If you want to think about how could you have used the formula, sine A is less than A over C is less than 1, I would definitely encourage you to do that. But in this case, I don't know if it's super necessary, but I'll leave that as a little thing there for you to think about here. How could we have used that here? Anyway, so that's that. That's the ambiguous case. Just remember, when you're given any kind of word problem, draw the formula, draw the picture, and then the formulas should work out. Okay, that's all for now.